The operations of Ti in S must appear in the same order in which they occur in Ti. This is an example of the schedule. To reduce the inconsistency, this is an best example, or best is known as a schedule. Now next is a conflict operation. The two operations in a schedule are said to be conflict if they satisfy all of the three following conditions. What are these conditions? The first one, they belong to different transaction. Second condition, they access the same item A, and the third is at least one of the operation is a right operation. For example, you can see if R1 is read, then A is write. If R1 is read, then write to operation. If R1 is read, then read to operation. This is the categories of schedule. You can say the schedule having main two type of categories. First one is a non-serial schedule and this other is serial schedule. The again non-serial schedule is divided into two main types. First one is serializable schedule and another is non-serializable schedule. And the serializable schedule again divided into two main types. First one conflict serializable and second is view serializability. So this is, we will discuss first what is an serial schedule. A schedule as is a serial if for every transaction T the participating in the schedule all the operations of T are executed consequently in the schedule. No interleaving occur in a serial schedule. For example, let T1 transfer $50 from A to B and T2 transfer 10% of the balance from A to B. Schedule 1 is a serial in which T1 is followed by T2 while T2 is non-serial as allow for interleaving of the operation. You can see in this slide where there are the two types of serial schedule T1 and T2, and another table also shows the operation T1 and T2. In the first table, the operation T1, that transaction T1 read the operation A, then again decrement by the 50 and operation is write, then read the operation B, B is increment by 50, then write the operation. It means transaction T1 is complete. Second table, the T2 read the operation, then store the value temporary A into 0.1, then A is in decrement by temporary value and write, then read, then B again increment with the temp. But this is non-serial, and you can see second table is the best example of serial schedule. First one, decrement the A operation in the transaction, then move the transaction T2 of the temporary value, then again read the B with the plus 50 values, then on the other side read the operation T2 with increment temporary value. So this is known as a serial schedule. Now next is a serializable. A schedule as on an AND transaction is serializable if it is equivalent to some serial schedule of the same AND transaction. Conflict serializability. A schedule is said to be conflict serializable if it is conflict equivalent to a serial schedule. They have the same sets of actions and each pair of conflicting actions is ordered in the same way. For example, schedule 1 can be transferred into schedule 2 which is serial, so schedule 1 is conflict serializable. You can see again the example on this slide. In the you can say in first table the transaction T1 read A and the write A, on the another side again read A, write B, then read B operation, then write B operation, then read B operation on transaction T2 and read B operation transaction T2. But on the next slide, the conflict serializable, read A operation, write A operation on the transaction T1, then read B operation and write B operation. On the other side, in transaction T2, read A operation, write A operation, then read B operation and write B operation. Next is view serializability. Let S and S dash be two schedules with the same set of transactions. S and S dash are the view equivalent if the following three conditions are met. What are these conditions? For each data item Q, if Ti reads the initial value of Q in the schedule S, then Ti must in schedule S dash also read the initial value of Q. For each data item Q, if Ti execute the read operation in schedule S and that value has processed by Tj, then Ti must in S dash also read the value of Q processed by Tj. For each data item Q in the transaction that performs the final write Q operation in the S must perform the final write operation in S dash. Then recoverable schedule. Recoverable schedule, if a transaction Tj reads a data item previously written by the transaction Ti, the commit operation of Ti appears before the commit operation in Tj. The following schedule is not recoverable if T9 commits immediately after the read. If T8 should abort, T9 would have the read, the possibility shown to the user, an inconsistent database state. Hence, the database must assure that the schedule are recoverable. You can see the table shows the example T8 and T9 two operations are here. The read A under the transaction T8 and write operation, then read A and read B. Then testing for serializability. This is a procedure graph, precedence graph, a direct graph where the nodes are transaction name. If we draw an arc for Ti to Tj, if the two transactions are conflict, then Ti accessed and the data item on which the conflict arose earlier, a schedule S is serializable if the precedence graph has no cycles. This is known as a precedence graph. The presence of cycle marks a schedule non-serializable. This is an example of Venn diagram of a serial schedule. You can see all schedule, then how they related with each other, then view serializability, then conflict serializability. Under this, the recoverable process, then ACA, then strict schedule, then serial process. This is next. We will move to locks. Locks are very important to the transaction processing. It used to stop the process until the next move to the next transaction state. So, what is lock? It is variable associated with each data item, describes status of an item with respect to operations that can be performed on it. Then there are basically two types of lock. This is binary lock. It has two states, then locked and unlocked. Multiple mode locks. It has three modes: read lock, write lock and unlock. Each data item can be in one of the three lock states. So, there are basically two types of lock: binary, multiple. Then binary have two modes: locked, unlocked, and the multiple mode has three modes: read lock, write and unlock. This is an example. You can see the example of locks. This is an example of lock system. Now, lock alone don't do the trick. It shows let's run T1 and T2 in interleaved fashion. Then there are two schedules T1 and T2. Then unlock too easily, non-serializable. It shows the whole operations under the two transactions T1 and T2. It shows how serializability and locking system are work together. This slide shows a very good example of result. You can see very easily how unlock system are work. Now, next slide goes to two-phase locking protocol. Transaction is said to follow the two-phase locking protocol if the locking operation precedes the first unlock operation in the transaction. Such transaction can be divided into two phases. First one, expanding phase. Second, new locks on the item are acquired but none being released. Then shrinking phase. Existing locks are released but no new locks are acquired. These are two types of phases in locking protocol. This is a slide show the functioning of two-phase locking. The expanding phase, that is lock under the lock manager, then commit and rollback, end of the transaction, shrinking phase, lock acquiring and lock releasing. This slide shows the functioning of two-phase locking. Again, the slide show the example of locking, two-phase locking. We have two transaction T1 and T2. Here you can see the transaction T1 and T2 both are follow the two-phase locking protocol. Any schedule including T1 and T2 is granted to be serializable. Limits are amount of concurrency. Now, variation to the basic protocol. There is conservative two-phase locking protocol and strict two-phase locking protocol. What are the difference between these two locking protocol? In conservative two-phase locking protocol, if the lock, it lock all the items needed before the execution begins by pre-declaring all read and write set. On the strict two-phase locking protocol, transaction does not release its exclusive write locks until after it aborts commits. Next, if any of the item in read or write set is already locked by other transaction has to wait and does not acquire any locks. It grants recoverable strict schedule. The strict two-phase locking transaction can either read write X until the last transaction that wrote X has committed or aborted. Now, concluding remarks are of the locking protocols are: the concurrency control subsystem is responsible for inserting locks at right places into your transaction. The strict two-phase locking is widely used, requires use of waiting queue, and 2PL locking protocol granting serializability, and it does not permit all the possible serial schedules. Then this is database recovery concepts. How the system can be recovered? If the system crash with the moving of 3 or more than 2 or 3 transaction, then the system crash, transaction error, system error, lock error, disk failure, catastrophe. These are the basic failure reasons. First, system crash, transaction, system error, local error, disk failure and catastrophe. Then how it can be recovered? Recovery from transaction failure means that database is restored to the most recent consistent state just before the time of failure. A typical strategy for recovery may be summarized. First one, if there is expensive damage to the white portion of database, recovery stores a past copy of database that was back up to the archival storage. When the database is not physically damaged, the strategy is to reverse those changes that cause inconsistency and doing some operations. This is logging. We having two backup and checkpoints. System log keeps info changes applied by transaction, here the crashing of transaction, then undo redo by the log, recover non-catastrophic failure, then full database backup, differential backup, catastrophic failure. This slide shows the logging. Now the physical view, how it works. We having a disk, having some disk pages divided into pages and block, then memory system, and the memory system having some DBMS cache that's stored into buffer, then directory having address. This is a simple example. And how it works, basically it checks the directory whether in a cache. Second, if none, the copy from disk pages to the cache. For the copy, the old buffer needs to be flushed from the cache to the disk pages. It shows how the basically recovery system works in your disk. Now next slide. Flush only if a dirty bit is 1. The dirty bit in a directory whether there is a change after copy to the cache. 1 it shows the updated in the cache and 0 shows not updated in the cache. Now again next example. A is known as a placing updated and the B operation shows shadowing. So these slides are shown the updating. You can see this is divided into a data blocks or log blocks. It copy the data from the memory to the disk into a data blocks, update the data and flush and log the unwanted data. So this is an example of. Then WAL. WAL is known as a write ahead logging. The recovery mechanism ensure that the BIF of the data item is recorded in the appropriate log entry and the entry is flushed to disk before the BF5 is overwritten. The operations are: a redo type log entry include the new value of the item, and the redo type log entry include the old value of the item. This is an example. Now, steal and no force. If the recovery protocol allows waiting an updated buffer before the transaction commits, it is called steal. The steal is used when the database management system cache need buffer frame from some other transaction. The T1, T2 and T3 are the 3 transaction operations. You can see how it works: store the data into the cache and move to the next. This is sometimes are known as a buffer space saving. Now, next operation is known as a force and no force strategy. The protocol ensures transaction need not to be written to disk immediately when it commits, otherwise known as a force approach. They are the again example of this slide. Advantages is input and operation saving, input and output operation saving. Again the cache forward the data to the next cache and store into the buffer. This is known as a forceful strategy and the force operation. Next, checkpointing. A checkpoint record is written into log periodically when the system writes out the database on a disk, all the DBMS buffers being modified. All the DBMS buffers modifieds are wrote out to the disk. The record is written into the log. This is known as a checkpoint and the periodically done every n minutes or in n transaction. This is an example How crash can be avoided with the help of checkpoints. Now, transaction rollback. If a transaction fails after updating the database, it is necessary to roll back the transaction. If any data item is changed by the transaction, it is to be restored to the BIF system. If a transaction T is rolled back, any transaction that is in the interim read the value of the data item X written by T must be rolled back. It is called cascading rollback, can occur when recovery protocol does not ensure cascading less schedule. This recovery methods not necessary: roll forward, roll back, roll forward and roll back. This is an example of transaction rollback. You can see again here transaction rollback with the help of an important example. We are using checkpoints where the data is crashed, then save the data into the buffer. This is again cascading rollback. Now, deferred update, that is no undo redo algorithm. It is restatement of the val operation. Database is updated to reflect the changes once transaction commits, so that there is never no need to undo the operation. The procedures are: maintain to list of transaction committed and active, redo all the write operations of the committed transaction, cancel the active transaction and resubmit it to the database. This is immediate update. Again, undo redo algorithm. Using this protocol, updates are applied to the database as they occur without waiting to the commit. Provisions must be made for undoing the effect of update operations applied due to the failure transaction procedure. Maintain to list of transaction that is committed and active. Undo all the write of the active transaction. Redo all the write of the committed transaction. Next is shadowing paging. This scheme maintains two tables during the life of the transaction. Shadow page table, it is never updated, changed using to restore the database in the event of system failure. Current page table, it is used to record all the updates to the database. Once a transaction commits, the current page table become the shadow page table. You can see example of a shadow paging. We having current directory and shadow directory and database disk divided into blocks and divided into pages. Now, what is database recovery? A major responsibility of the database administrator is to prepare for the possibility of hardware, software, network process or system failure. If such a failure affects the operation of a database system, you must usually recover the database and return to normal operation as quickly as possible. Recovery should protect the database and associated users from the unnecessary problems and avoid or reduce the possibility of having to duplicate work manually. Recovery process vary dependent on the types of failure that occurred, the structure affected and the type of recovery that you perform. If no files are lost or damaged, recovery may amount to no more restarting an instance. If the data has been lost, recovery require additional steps. These are the basic errors and failure types of failure. Several problems can halt the normal operation of an Oracle database or affect the database input output to the disk. The following action describe the most common types. First one, user error. A database administrator can do little prevent user errors such as accidentally dropping a table. Usually user error can be reduced by increasing the training or database and application principles. Then statement failure. A statement failure occur where there is a logical failure in the handling of the statement in the Oracle program. For example, assumes all the extent of a table, max events and etc. Then if a statement failure occur, the Oracle software or operating system returns an error code or a message. This is a statement failure. Then process failure. A process failure is a failure in user, server and background process of a database instance, such as an abnormal disconnect or process termination. When a process failure occurs, the failed subordinates process cannot continue work, although the processes of the database instance can continue. Then network failure. When your system uses networks such as local area network and phone lines, or to connect client workstation to database servers, or to connect several database servers to form a distributed database system. Network failure such as aborted phone connections or network communications. A network failure might interrupt normal execution of a client application. Again, network failure might interrupt the two-phase commit or disturb the transaction. Database instance failure. Database instance failure occur when a problem arises that prevents an Oracle database instance from continuing to work. An instance failure can result from a hardware problem such as power outage, or a software problem such as an operating system crash. Instance failure also results when you issue a shutdown, abort or startup process. Recovery from instance failure. This crash or instance recovery recovers the database is to transaction consistent state just before the instance failure. Recovery from instance failure is automatic, requiring no DBA intervention. For example, when using Oracle parallel server, another instance performs instant recovery from failed instances. In single instance configuration, Oracle perform crash recovery for a database when the database is restarted, that is mounted and open to new instance. Rolling forward to recover data that are not being recorded in the data files yet has been recorded in the online redo log, including the contents of rollback segments known as a cache recovery. Opening the database instead of waiting for a transaction to be rolled back before making the database available, and marking all the transaction system wide that were active at the time of failure as dead, and marking the rollback segments containing these transactions as partially available. Rolling back dead transactions as part of the SEMON recovery. This is again are known as transaction recovery. So, this was a topic of the database management system, transactions and recovery failure. Thank you.